I'm hoping to conduct 4 sessions to cover up IoT section, Internet of Things, and this session, like all 4 sessions of IoT, is going to be free for all of you kids. That's a good news, I guess. And nope, it's clear by Rifat. And this session, as sponsored for most of our events, this session is also sponsored by IIT for you all. Yes, you know, Informatics Institute of Technology, sponsored by them. We have some theories prior to go for the practicals. Like prior to go for the practicals, we have some theories to cover in IoT session, right? I hope all of you are ready for the theories as well. And before starting off with theories, I will tell you what are the software that you have to get ready with. Right, fine. So let's get going. First of all, what do you mean by a smart world? Goodness, what is this? Smart world. Shall we like read this and see whether we can say this? The Internet of Things is a technology that connects smart devices such as mobiles, electronic home appliances, television, air conditioner, refrigerator, washing machine, etc., advanced medical equipment and other machinery to the internet using wireless technology. Wait. How many of you are using smart devices? Yeah, all of you. Goodness. Wow, you are all smart people. Right. So we have smart watches, smart phones, everything smart. So it's going to be like, in future, it's going to be like fully smart world, right? Where all the devices connected. No security at all among people. All of their, what did I just say? No security at all. There are security measurements, but at risk. Wait. Let's see. IoT. IoT. What do you mean by IoT, you think? Teran? IoT? Do you know IoT? Is it Teran? Seriously? No, IoT means not Teran, okay? I must tell you that. IoT is not Teran. First of all, telling you that. IoT means basically IoT. Okay, IoT supports to connect smart devices. That is your mobile phone, your smartwatch, whatever the things smart around you. Not only that, lot of things. What do you mean by IoT? T means here things. What do you mean by things? Tell me some things. Come on. I need some examples for things in the chat screen. Come on, tell me some examples for things. Things. Mobile phone is a thing. Phone is a thing. Pen is a thing. Exactly. Mac is a thing. Lap is a thing. Fridge is a thing. TV is a thing. Light is a thing. Tablet is a thing. Stick is a thing. Thing is a thing. Who's that? Luanga. Ruler is a thing. I am a thing. Headphones is a thing. Eraser is a thing, like anything. Okay? This thing, that thing, all the things. Internet of Things. All of these things connected with each other. Just imagine a world where your perfume bottle connected with your smartphone. What? To do something. I mean, just imagine. Can you imagine? Are you all imagining? Are you all imagining? Are you all imagining? That's what I need. Great. So let's see like what is mentioned in here. IoT systems are also referred to as smart connected systems. They are like connected with everyone. Okay. The Internet of Things, IoT, describes the network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices. By Wikipedia. Can you understand anything by any chance? Come on, kids. Can you understand? It is clear? Come on, is this clear? Yeah,
No, sir.
exactly. No, not for you. No. So let's go for the next one. We have some topics to understand IoT, right? One is English, please, and vote of thanks, dumb devices, merging the universe, and finally. These are the topics that we need to cover up to understand IoT, the term. Look at the topics. English, please. Vote of thanks, dumb devices, merging the universes, and finally. Wow, very relative topics, right? Have you ever seen these kind of topics in your life? Obviously, no. Never. Look like crazy, right? I mean, if the topics are crazy, don't you feel like it's cool enough to learn? Yeah? I mean, look at these topics, dumb devices, merging the universes. What is this, like sort of DC and Marvel universes? What are we talking about here, right? And English, please. Okay, that looks like a topic. What is that? Like some sarcastic 2 words. English, please. Vote of thanks. Wow, trying to be very official. Finally, it doesn't make any sense. Wow, some nonsense topics. Okay. Are you ready for the nonsense topics to understand IoT? Are you all ready for this? Come on. Are you all ready for this, kids? Perfect. Okay. Here we go. Starting off with the nonsense topics. First one. English, please. Okay. English, please. First of all, understanding this IoT in English. The Internet of Things, or IoT, refers to the billions of physical devices. Like imagine devices, you know devices, right? Obviously. Billions of physical devices around the world that are now connected to the Internet and all collecting and sharing data. They are all like sharing data with each other a lot. Can you imagine that? Can you understand this? But that's IoT. That's IoT. Devices like connected goodness. Okay. Let's start. Exactly, Ashfaq. Let's write down the topics. IoT, under that one, first one, English, please. Come on. Write this down, kids. Write this down, kids. Come on, everyone. Write this down. What do you mean by stuck, sir? Fatima Sumeya. What do you mean by stuck, sir? Fine, come on, let's write down. English, please. Come on, write down. IoT, Internet of Things, under that one. First topic. English, please. No, you don't need to have a separate book for this session. You can just write it in whatever the book that you have, no problem. Come on. Where to write? Very good. Write on your desk. Or your chest if you want. Use a book, a pen and a paper. Thank you very much for listening. Come on, write down. English, please. Come on! Let me know once you're done. Come on, we have a lot of kids in here. Quickly write down. Quickly write down. Please, please write down. Are we going to count the number of dones today, Teran? You won't be able to do that. No, we are not talking about LPL here. We are talking about IoT, guy. And you got it? What is LPL? Yeah, you can use the exactly. Why not Imad? Yes, you can. Yes, just this topic is nice enough, right? Come on. Let's do this. Oh, Lankan Premier League. So these Internet of Things. So what do you say? Thank you, Muhammad Simak, for telling me what I love. Thank you. Right. Okay, everyone done. May I proceed with the next one? Is there anyone who's still writing? Come on. Anyone still writing? Come on. Anyone still writing? Done, right. Okay, going for the next one. Next topic. Word of thanks. But a word of thanks supposed to be at the end. But yeah, we are going to mention it at the as a second one. Word of thanks. All right. Look at this. Word of thanks. Can you all see this text? Weights are still writing. Seriously, Ashfa? Goodness. Make it quick. I'm not going to give time for the next one. Come on, quickly. Quickly. Right, Vilya? What are you writing in addition to this? Like the things that I talk continuously? Okay. Right. Fine. Then going for the next one. Word of thanks. Thanks to the arrival of super cheap computer chips. Whoa. Are we talking about French fries here? Oh, potato chips? No, these computer chips. Now, don't go to the shop and don't go to like those, what do you call, Food City or Heel Super or Apico Super or whatever, right? You don't go for those shops and ask from them, do you have these, not potato chips, you have computer chips with you? Yeah. This is not something that you can eat, okay? So chips doesn't always talk about the things which digest, all right? You got it? You got it? Fine. Okay. Thank you. Thank you very much for listening. So here we have super cheap computer chips and the ubiquity of wireless networks. We have wireless networks everywhere. Ubiquity. Obviously, yes. After Corona, I think now you have enough of wireless networks at your home, right? I guess so. It's possible to turn anything from something as small as a pill. I mean, look at this term. Something as small as a, where's my annotation? Where's my pen? Something as small as a pill. A pill to something as big as an aeroplane into a part of the IoT. Whoa! Look at that. Okay, I don't think it's a problem with my side that it's getting stuck. Ilma? Is the connection clear, everyone? Come on. Yeah. So it's from your side if you have a problem. Internet connection problem, probably on your side, I guess. Yeah. So here, possible to turn anything from something as small as a pill, you know pills, right? You know pills, right? I'll show you. It can be something big like this. It can be a small pill. Yeah, like that. Okay. Yeah. Connected to Internet of Things, like a pill having a chip inside to get connected to wireless network. Wow. Just imagine that technology. I know, Imad, you can see. I know. Right. Okay, then. Can you all understand this now? Can you all understand this now? Yeah, right? Exactly. So come on, let's write this down. Word of thanks. Thanks to what? Thanks to the arrival of super cheap computer chips. Thanks to them, we can use it in that way. Like super cheap ones. Like for 100 rupees, you can buy certain chips. That is with the tax and everything in Sri Lanka. So imagine the real price of those. $1, $2, goodness. Come on, write down. Ubiquity means available everywhere. Ubiquitous. Right. So basically, you can connect anything from smallest pill to a big aeroplane, thanks to what? The super cheap computer chips available. These chips are capable of getting like connect all of those types of different things in the world. That's it. Come on, write this down. Come on. What? To have some sweets? No, Vidushi, but I saw your message. Goodness, to have some sweets. Anyone still writing? Finally up.
Anyone still writing? Finally up.
Oh my goodness. Whose mic is that? Hey, Sadib, mute your mic. Right, come on. Fine. If you can tell about the pill and the aeroplane again. Pill having a small chip inside it to get connected to the internet. Aeroplane having a chip inside to get connected to the internet. That's it. Think like that. Okay. Right. Forget about that, Aisha. And then let's go for the next one. Down with word of thanks. Right? So we are done with 2 topics. Can you remember? Tell me, we are done with 2 topics, right? What are those? Come on. Quickly type. Quickly type the 2 topics that we are done with. We are done with. We are done with. We are done with. English, please, and. English, please, and. Word of thanks. Perfect. The first proper answer given by Hafsa Rizvi. Right. So English, please, and word of thanks. Right. Wait. We have 3 more topics. Dumb devices, merging the universes, and finally, what will be the next one? What will be the next one? Come on, what will be the next one? Next topic, next topic. Tell me, what is the next one? What do you think? Dumb devices? Wow. You have a sense. Great. Goodness, my kids have some sense. Perfect. You are the best. Right. That's the writer, Kalindu. I have given proper credits to that writer. So here, dumb devices. Connecting up all these different objects and adding sensors to them. Like, okay, like different objects and adding sensors to them, and adds a level of digital intelligence to devices that would be otherwise dumb. Okay, wait. I'll take it. I'll explain it. Okay. Catching up all of these different objects. Okay, tell me a different object. Tell me an object. I'm going to take a fan. You know fan, right? You know fan, right? Okay. Exactly. Right. So fan. And adding sensors to them. What to do to the fan? I'm going to add sensor to the fan. What is the sensor? Just imagine temperature sensor. Okay. Adds a level of digital intelligence so that the fan will become something with a little bit of more intelligent device. How does that happen? Okay, how many of you want at least the sound of fan for you to sleep? Come on. Obviously. How many of you, but sometimes feels like that the weather is little bit like too cold, so therefore you are going to turn off the fan in the middle of the night. How many of you have done this? Okay, Chandup is like, I'm on AC. I don't care. I'm talking about fan here. I don't care whether you have AC or not. Goodness. Obviously, you know, some of you are going to like turn off the fan in the middle of the night sometimes because it's too cold. Obviously. And what happens to you is that within that few seconds of time, or maybe for that 1 minute, which you are going to turn off the fan, you are going to become a zombie. Yes. Who is going to wake up from the dead and then reach the fan and then switch off the fan. How many of you have experienced that? Come on. Exactly. Now, if you have not experienced, you don't have to say, not me. Why are you saying that? Fine. Okay, so you have experienced that. Great. So, what if the fan has a little bit of intelligence? Okay. Let's say your fan has a little bit of intelligence. You have connected a temperature sensor and you have programmed the fan to turn off at a certain level of temperature. It's going to detect the temperature in your room and then it's going to turn it off if it has reached a particular temperature level. And that kind of fan, can you just call it a fan? No, it's an intelligent fan. Yes or no? Yes or no? That will be great. Exactly. Something smart, something nice. Okay. Now let's say your device, your fan, that object that I'm talking about has a sensor, temperature sensor, and we have programmed it, and then it has a digital intelligence because it's programmed to turn off, reaching temperature level. Right? So this is programmed to turn off reaching a temperature level. Super digital intelligence. Okay. So let's say you go to one of your friends' houses. Okay. You go to one of your friends' place, and then your friend says that, hey, you can let's say, okay, your friend is saying, hey, you don't need to go home today. You can stay overnight at my place. Are you going to accept it or not? Some of them are saying yes, some of them are saying no. Depends. Okay. Some of them are saying I will accept, but the problem is my parents will not. Some of them are saying pajama nights. I don't care whether you are going to have a pajama night or whatever night. Okay, right? I don't care whether you are going to say accept it or not. What I'm trying to say is that, let's say your friend's house has a fan, okay, which does not have these sensors and which is not programmed to turn it off automatically, right? So in the middle of the night, there goes the fan and the temperature is too cold. How you are going to bark at the fan? Saying what? Saying what? Not stupid fan anymore. You have the word in here. You have the word in here. Dumb fan. Yeah, you dumb fan. Not only that, telling to your friend, you also are dumb. Look at your face, you dumb. Right? And look at that fan. Your fan is also dumb. Your everything is dumb. Okay? Because you have experienced something intelligent. Something intelligent. Digital intelligence. Okay? So digital intelligence to devices that would be otherwise dumb. Otherwise it would be dumb. Enabling them to communicate real-time data without involving a human being. Without involving a human being. This is super important. Without involving a human being doing that. Wow, intelligent. Your fan is intelligent because it can truly do something without you being involved, but not your friend's fan. Okay, fine. Can you all understand this, kids? Come on. Can you all understand this, kids? Right. Okay, kids. Come on, let's write down dumb devices. If you want, you can mention the annotations if required. Come on, kids, write down dumb devices. Let me know once you're done. And you must be thinking like, what are we going to do With the Arduino, you told us to purchase the Arduino kits. What are you going to do? So waste some money. Wait for it. We are going to develop these things. Wait for it. First of all, theories for a proper foundation. Come on, kids, write this down. Yeah, don't worry, Siluni. Yes, Netulya, intelligent fan. Goodness, yeah, right, Aisha. Yahya is missing. Anyone still writing? Anyone still writing? No. Okay, there is one. Come on, quickly. Quickly. Whereby IoT? Goodness, Ashfaq, is that a question to ask? Somebody please answer that. All right, shall we proceed? Okay, next one. Whoa, dumb devices. So you all know what's our next topic. Come on, we have two topics, merging the universes, and finally, come on, tell me, come on, what will be the topic? Oh, goodness, Nenura. Merging the universes. Merging the universes. Are we talking about DC and Marvel here? Yes or no? Are we talking about DC and Marvel? Obviously no. Then what are we talking about? The universes which exist in our world. Universes which exist in our world? Yes. Let's see. Merging the universes. Look at this. Merging the universes. The Internet of Things is making the fabric of the world around us more smarter and more responsive. How? Merging digital and the physical universes. Our physical world thinks with the digital world stuff. This gap is bridged properly with the use of IoT kids. So we have digital world things appearing in our physical world stuff communicating with the digital world. Wow! Universes merge together. So it's digital and physical are the universes, kids. Superb. Nice, yeah? Nice, yeah? Come on! Right, kids? Let's write this down. Write this down. Come on, make it quick, make it quick. You have some more interesting things to come. Come on. Come on, quickly. Oh, aliens, are you serious, Nidmi? Come on. Aliens. Let's talk about universe. Seriously? Which means you're talking about aliens by Nidmi. Right? Anyone still writing? Come on, in the chat screen. Anyone still writing? Anyone still writing? Wait. Okay, fine. Oshara is like, wait. Fine, okay. No worries. Take your time, but make it quick. Mr. Yasin, Sugatapala, your I have to mute him. Yasit Sugatapala. Okay, I have a solution for that. Right, kids. What do you mean by pop-ups? What's the problem with the pop-ups? You can pin the screen so there won't be any pop-ups. Don't worry. Use the pin option. So the chat pop-ups won't be there, kids. Pin the video. Everyone try pin the video. How? Okay, can someone please tell how? Come on, support Ninura. Right. Ah, seriously. Your mic was bugged. Right. It is supposed to be not working then. If it is bugged, I think it's working perfectly. That's why it turned on. So don't worry. Congratulations. Your mic is working. Fine. Okay. Fine. Right. Right. So here we go. Next one. Ready for the next one? Finally. Ooh, finally. The term IoT is mainly used for devices that would not usually be generally expected to have an internet connection. What? Wait. IoT means Internet of Things. Yeah, right? I mean, IoT means here IoT. Where's my annotations? I'll take it here. IoT means Internet of Things, right? The first I is Internet, right? I mean, yeah, right? Yeah, right, kids? Exactly, but what? The term IoT is mainly used for devices that would not usually be generally expected to have an internet connection. Oh. And that can communicate with the network independently of human action. Whoa. So here internet means actually connected to a network. It's not just the internet that we are talking about where we can surf World Wide Web. Not that, just connected to a network. So if the devices are like simply connected to each other within a network, that is still IoT. A connection can be made either wirely or wirelessly. IoT still. Oh, perfect. You got it right? You got it right? Yeah, thank you, Chandupai. I don't know what are the rhymes that I said. Fine. So they are like all synchronized with each other. Wow. Write this down. Come on, kids, quickly, come on, write this down. What are the benefits of studying IoT? You're going to see that. You're going to see that. You can experience the benefits. Wait for it. Come on, quickly write this down. Let me know once you're done, kids. Come on. Some interesting things to come up. Why not Vidushi? This is syllabus, yeah. This is in our syllabus, yeah. Anyone still writing? Anyone still writing? Come on. Anyone still writing? Okay, okay, okay. Take your time. Take your time, but make it quick. Mohammed Iqbal Rashid Ahmed. Goodness. Did you add your friend's name to your name too? Yeah? It's like only your name? Ah, your full name. Yeah. Ah, glad to know that. Exactly. Watch 100. Yeah. That's correct. Adil, watch 100. Yeah. Fine. Okay. Let's go for the next one. Take your time and make it quick, interesting combination. Yeah, right, Nedmi? Fine. Okay. Then let's go for the next one. Right. What? Okay. Then. So what are we gonna do? This is what we are going to do. Use the microcontrollers to develop IoT systems. Wow. Sound interesting, but cannot understand the situation. Brought to you by itguru.lk. This sounds interesting, yeah? Use the microcontrollers to develop IoT systems. Wow! But how? Sort of situation, right? Yeah, right? Come on, yeah, right? Fine. Exactly. So what's next? Subtopic 1? No, seriously, no, what's that? Then, going for the next one. Microcontrollers versus microprocessors. This is super important. Microcontrollers versus microprocessors. The second one is quite familiar, right? Microprocessors, do you know that? Where can we find microprocessors? Yeah? Phone, yeah, very good. Anywhere else? You better say smartphone, huh? You can't find it in your like very smart, like, what do you call the legacy devices? No. Legacy devices you cannot find, obviously. CPU, yeah. Basically saying laptop computers, we have microprocessors, right? We mentioned Core i5, this thing, Core i3, Core i7, Core i9, this thing, that thing, M1 chip. All of those are what? Microprocessors, right? Exactly. Then what do you mean microcontrollers? Okay, there is a difference. The difference is that microcontrollers are meant to do only one specific task. Now, this is super important. Microcontrollers are meant to do only one specific task. Just one specific task. Microcontrollers, one specific task. But when it comes to the microprocessor, can perform multiple tasks. Microprocessor can perform multiple tasks. Microcontroller meant to do only one specific task. One, multiple tasks. Okay, super. Right, come on. Right, come on, write this down. Come on, quickly. Microcontrollers versus microprocessors. Come on, quickly write this down. Let me know once you're done. So while you are doing this, just looking at your chat. Examples. Wait, I'll give you examples. Just wait for it. Everything is there. Wait. Step by step. Oh yeah, Ryzen 5600, Intel, M1. Yeah, all of those are microprocessors, kids. Yes. Fine. What is more efficient? Depends on the application. For Internet of Things applications and most of the embedded systems, we are using microcontrollers. Like washing machines do have microcontrollers. Yeah. Washing machines don't have microprocessors because you are not going to say that, you know, you know what, I just played Call of Duty using my washing machine. No, obviously no. So that's why you don't have a microprocessing there. Right. Fine. Wait, Arduino chip, everything, the answers will be given. Right. Why don't you manufacture microprocessors? I'm not interested. Fine. Fine. Think it's a problem in your side, Afsa. Fine. So let's proceed. Going for the next one. What's the next one? Subtopic? No. Then what? Any subtopics? No. Okay, kids. We have a lot of theories in our tute which we will be following along with our practicals. We got to do some practicals as well. No? Obviously, yes. So we have more in our tute. You can visit this link and access the tute, or else you can just scan this QR and it will lead you to access the tute straight away. Come on, you can do that. Come on, be smart. Scan the QR. Just open up the mobile phone camera, scan the QR, and just open the link. That's it. You will get the tute. Yes, Adya. Yes. So those who are accessing with your phone, you can access the link using this. You can maybe bookmark it, right? No worries. Fine. Right. The link is mentioned there in the chat screen also. Okay. That's it. Lot of links, right? So I just access the tute. So this is the tute. Got it. Right. So microcontrollers, I know it's not clear to you. You cannot see this, obviously you cannot, right? I'm going to change the view of that, right? So before going through the theories of it, we are going to do some practicals. We are going to understand some practical concepts. Is that good, kids? What do you say? The link again. Can you please mention the link again, Akzaint? Thank you. Right. So this is that website that I was talking about, Tinkercad. I hope all of you have created a profile in this. All of you in the sense, at least the ones, those who don't have the Arduino kits. those who have, you can actually learn Arduino using this. Yeah, we are going to use this a lot. Okay, let me first of all point to this properly. Right, here we go. Okay, fine. So this, can you all see this first of all? Can you all see this? Yeah? Okay, so how do you get in here? Like, how are you going to reach this level? Wait, I'll tell you. Wait. Let me make it even more clear. Ah, you can see it, right? Yeah, you can see all the text and everything, right? Obviously. Yeah. Who's saying the camera is not focused? It is focused, I guess. It is, yeah, it is. See? It is. It's clear. See? All right. Fine. Microcontroller. Woo. The devices. Those who have purchased the Arduino. So until others get in here, I'm going to show you the Arduino stuff. So it's going to be Tinkercad. And when you sign into Tinkercad, there is something called circuit design. Just choose that circuit design option, and then you will be able to see this, right? Okay. So, how many of you have received, how many of you have got this? I mean, not received actually. How many of you have bought the Arduino Uno? Perfect. Let me turn on the other flash as well. Is it even more clear now? Yeah, right? It's too bright. Two flashes. Wait. How's the situation now? Much better, yeah? Situation now is much clearer, right? Kids? Yeah. And you all can see this as well, right, kids? Great. Fine. Ah. Only thing is that with the two flashes, it gives me some headache. Right. Okay. That's fine. So here we go. You have Arduino board and this small thing zoomed in like this. Otherwise, me teaching you, it's going to be like, kids, can you all see the Arduino board pins? Can you all see? No, you cannot see because the camera is not focused. And then I'm going to go here again, switch to autofocus, and then show you again. Let's give it a try. Autofocus. Kids, can you all see this now? Yes. Now you'll be like, yes, because now you can actually see it. Obviously, yes. Right. Go, crystal clear. Right. Now that thing zoomed in, more cartoon-ish version is this. I mean, let's try to understand what is this. So this is Arduino Uno, brought to you by Arduino. Yeah, brought to you by them. Not Panadol, come on. Fine. And then I'll show you another. Now that is a microcontroller enabled one. This Arduino Uno has a microcontroller inside it. There is a microchip called Atmega 328P. What? Wait, those things are there in your book. Don't worry. The tune. Don't worry, right? So this Arduino Uno. Fine. And then we also have another one. Don't worry, you don't have this. This is microbit. Focus. Microbit, BBC microbit. Oh, you have some lights also in here. You can see array of LEDs. Goodness. What for me? And then we also have the smaller version of Arduino, just to show you, show off time, okay? Show off time. And this is Arduino. Look at the size, nano. Can you all see that? Yeah, that's what you focused. Good. Right. Wait, kids. We have another one of the smallest computers in the world. That is one of the, okay. This is not having a microcontroller. This is like system on chip version. This is like a microprocessor is there, but it's not basically like simply a microprocessor also, like system on chip version of the computer, that is Raspberry Pi with a casing. You can see that. I have fixed a casing for that. Raspberry Pi, you can see USB ports and network port, and also on this side you can see HDMI sound output and the power port. Raspberry Pi. Yeah, okay. So basically some devices. So if I'm going to like show off all the devices in here, you know, that's going to be like, you know, just show off show. So it's not going to be any lessons for you all. So, right. So first of all, we need to know about Arduino Uno. We are going to learn Arduino Uno, and we are going to use that Arduino Uno for this entire session of IoT. Okay. Are you all ready, kids? Are you all ready, kids? Are you all ready, kids? Don't worry, you don't need to have all of those things which I have said. Perfect. How to get into that Tinkercad.com website? The best part is that one is mentioning the website name in the chat. Tinkercad.com. Go to Tinkercad, go to sign in, use the sign up option, use your Gmail to sign up, and then quickly you can sign into that. It's very simple. Come on. It's very, very, very simple. Come on, everyone. Okay. Wait. Oh, come on. Right. Here we go. Which design we should choose? Right. I'll show you how to use the Tinkercad. Right. Let me move this a little bit. Fine, so that you can see me as well. Right. Tinkercad. Refresh. Okay. When you initially go to Tinkercad.com, I'm going there. Tinkercad.com. Just showing you how to access this first of all. So I'm going to tinkercad.com. I have already signed in, it seems. Let me log out. You have this option to join now. I'm going to use sign in, and you can straight away use sign in with Google if you want. I mean, if you want it to be embedded with your device, with your Google account. So I have used my Google account to sign into that, and then afterwards it's going to get signed in. That's it, and you will end up in here. You will end up in here. So here in the left side, you will be able to see this. That is, you have 3D designs, circuits, code blocks, lessons likewise. That's very simple. Okay. So, right. So this is where you should be. And also, those who have the Arduino with you, you can simply open up the Arduino software, right? Which is not, I have installed in here. Yeah, so what you can do is you can install the Arduino software, and yeah, make sure that you have Arduino software with you to proceed with this session. That's it. So all of you have Arduino software, at least you have code blocks, sorry, not code blocks, Tinkercad, that will be fine. So how many of you are in here now? Come on. How many of you are in here? Come on. Okay. Now, those who have the Arduino kit or not, doesn't matter. If you want, you can use this. You can practically use the Arduino kit also according to the instructions that I give in here. That is the best part, right? Okay, fine. Don't use the Arduino software in Microsoft Store. No. Download it separately and install it, because it will get installed with the drivers in that case. Fine. Okay. Come on, are you all done with this? Come on, if you are in here, please mention done in the chat screen. Come on, quickly everyone. If you are in here, if you can see on your left 3D design, circuits, code blocks and all, we have this create new design, and this is their home page, sorry, the dashboard. So yeah, if you are in here, please mention done. Come on. You must be able to sign up. Come on, it's a very simple process. Just don't worry. We won't be doing much of practicals today. Don't worry. All of these things, you have time, okay? You have time of 1 week for you to get prepared for everything, and make sure that all of your accounts are working, maybe in Tinkercad, and also you have installed the Arduino. I'll be sending you a small video tutorial to check your Arduino is working or not during, like, within this week, okay? So that you can make all of your things ready for the next week session, which is going to be like full of practicals with a little bit of theory. So it's going to be like full of theory and a little bit of practicals today. So don't worry. Right. Okay, kids. Fine. So here we go. Click circuits. Click circuits, and you have the option to create new circuit. Okay, I'll use that. Create new circuit. Okay. And this is what I have in black. You must be having this in white screen. Don't worry. Okay. You can even access it using mobile phone. Yeah. Okay. Right. So you must be having a white screen. Don't worry about that, because this is something, I have installed a small add-on to actually a small extension to Google Chrome. So as a result, like, everything is black. Whatever I open, it's going to be in black. So that's why the dark mode in here. Okay. That's why, like, everything is in dark mode. Like, let's try Google. Yeah, even Google is in dark mode in my case. Hello. Yeah, see? Okay. Right. Fine. Right, everyone okay? Right, let's talk about the extension. You can just simply Google it. I'll send it to you by the groups. Right, so we have a lot of components that we can use in here. On the right side, you can see that. Can you all see that? The components, the basic components. Come on, yes or no, kids? Come on, yes or no, kids? Can you all see the components? Yeah? Yeah. Come on, yes or no? Yeah, right? Cool, fine, right. All right. I think so, Jonathan, yeah. Right. So now, what I'm going to do is I'm going to choose Arduino Uno from the components, and I'm going to add this component, Arduino Uno here. Right. I have added Arduino Uno component here. Right. And once you add a component, you can give a name to it. I am just giving it as my Uno, me Uno, whatever name, right? This is my Uno, okay? Not me Uno, right? Let me try taking this to full screen. Oh, right, that's great, fine. Okay. Yeah, by clicking circuit, create new circuit and selecting Arduino Uno R3, that's it. And here we go, we have Uno R3 in here. Okay. Fine, by the way, can you all see this, kids? Come on. Can you all see this? Can you all see this? Yeah, that's it. Very simple. I have enabled the autofocus. Wait, let me make the board clear to you all. All right, now the board must be clear to all of you. Right. It's okay, Nasif. If you want, you can, yeah. If you want to see this, like see this thing also, then you can practice this also. No worries. Right. Don't worry. We are not going to do much of practicals today. Right. So here we go. We have the Arduino board, the one physical and the virtual one both. So those who don't have the Arduino board, you can look at the virtual one. Those who have the Arduino board, you can look at your Arduino board. All right. You can see that. Fine. So now let's open up. Let's go to the Diode. What it says. Microcontrollers. Yeah, some theories again. Can you all see this text, kids? Come on. Can you all see the text? Come on, yes or no? Yeah, right? Yeah, right? Fine, perfect. Okay. Let me turn off the flasher. How about now? Way better? Right. No. The previous one was better? I mean, you can, I have shared the Diode with you. Please access the Diode using the link, kids. Okay? Right. Please access the Diode using the link, kids. Okay. All right. So here we go. So a microcomputer is a simple computer that can generally run one program at a time and very simple to use. This is very simple to use. All right, fine. So it's very simple to use and it can run only one program at a time. And then a microcontroller is a single chip that contains a CPU. Come on, please, you can open up the Diode I have sent you the link. Can you please mention the link again, Akzayant, in the chat screen, please? Yeah, thank you very much. So a microcontroller is a single chip that contains a CPU, memory, and programmable input-output peripherals all in one. Wow, I mean, microcontroller has like all of those things, CPU, memory, and everything in like one single chip. Say wow to it. Say wow to it. Thank you. Fine. And then Arduino Uno is based on an 8-bit AVR microcontroller. AVR is a family of 8-bit microcontrollers developed by Atmel, the developers, the history and stuff, you know. Atmega is one family of AVR microcontrollers. Here comes the history. For example, the Arduino uses an Atmega 328P microcontroller. Wow! Do not forget that. I mean, if I have written the notes, the previous notes in the book, I would definitely, I won't be looking at the tute much. So therefore, what I'm going to do is I'm going to mention the important ones in the tute in my book as well. What is that? Atmega 328P microcontroller. Shall we use a different color for that? Atmega 328P microcontroller. Oh, come on. Atmega 328P microcontroller. Look at that. Atmega 328P microcontroller is there in Arduino. This is super important. There can be MCQs from this. Atmega 328P controller is there in Arduino Uno. Super important. Come on, highlight it or else write it down in your writing book, kids. Come on. Fine. And then other Arduino boards use different microcontrollers. Some of them a lot more powerful than the one used in the Arduino Uno because they are like more powerful ones, right? Arduino Mega is there, right? Arduino Nano, which is a small one. Likewise, different versions of Arduino is there, but we are using Arduino Uno. Each and every Arduino Uno has definitely Atmega 328P microcontroller, right? And then Raspberry Pi, we are talking about something else here. Something else. Raspberry Pi is a low power and small size full computer. It's a general purpose computer. Wow, you can install an operating system like Ubuntu in here? Yes. Raspberry Pi is neither a microprocessor not a microcontroller. The device which I showed you, can you remember? The one which was with the USB ports and the HDMI, can you remember, yes or no? Yeah? I showed it to you. Yeah, exactly. Yeah, that's what. Yeah, so that one, it's not a microprocessor based, it's not microcontroller, it's a single board computer which contains SoC, system on chip, which means it has multi-core processor, a multi-core processor, not just a normal processor. It can be dual-core, quad-core. Wow. GPU, ROM, IO peripherals inside it. Like in that single board, you have everything. System on chip. DDR, RAM, memory, Ethernet port, USB host, micro HDMI, everything like HDMI, everything like everything. Wow. Fine. And the best part is Raspberry Pi is based on 32-bit microprocessor. Look at this. This is 32-bit while Arduino Uno is 8 bits. Okay, Raspberry Pi 1 and Raspberry Pi 2. But Raspberry Pi 3 and the latest ones, they are 64-bit microprocessor based systems on chip. Wow. Which one is faster, you think? Which one is faster, you think? Where is that? Which one is faster? Which one is faster? 64-bit one or 8-bit one? What I'm talking about is Arduino Uno is faster or Raspberry Pi is faster. What do you think? What do you think? What do you think? Kids. Raspberry Pi needs to have an operating system. On top of that operating system, you are running whatever the software. Okay? Don't forget that. Whereas Arduino Uno, it's not like that. Let's take them. Raspberry Pi, Arduino Uno. Raspberry Pi, yes, system on chip, very powerful. This is 64-bit Raspberry Pi version 3. This is Raspberry Pi version 3, okay, 64-bit one. This is Arduino Uno, 8 bits. This one needs to have an operating system. On top of that, the programs are running. This one, program is embedded to the chip, directly executing the program. When it comes to embedded systems, trust me, Arduino Uno is much faster than Raspberry Pi. Don't forget that. It's not always about the processor and the RAM and the stuff. It's all about the application. Is that clear, kids? Is that clear, kids? Why is that? Because in the Arduino Uno, we are programming straight away onto the chip. This one has a memory card in it. I'll show you. Come out the memory card. You can see there's a memory card of 8 GB which I have installed into this, right? 8 GB memory card. So this memory card has the operating system and all the programs that it requires. Yeah, but here we are straight away storing the program inside the chip. We are programming it. It's embedded systems. So have a look at this embedded systems note, which is given in the Diode. Embedded systems. Embedded systems is the embedding the software with hardware to make a system. Hardware part in embedded system is the microcontroller chip, and software part is the program code running on this chip. So the hardware part is the microcontroller and the software part is the program which is running on the chip. Running on the chip, it's on the chip again, right? Microcontrollers is the body of any embedded system. Software is the mind which controls the complete behavior of the system. So basically there is no difference between embedded systems and microcontrollers. So basically what we can say is that embedded systems are microcontrollers. Embedded systems uses microcontrollers because microcontrollers are embedded systems. Is this clear, kids? Come on, is this clear, kids? Is this clear, kids? Yes or no? Come on. Perfect. Okay. Here we go. Scrolling down. So we have a big comparison of microcontrollers and embedded system. You can go through that. And then here we go. Arduino Uno R3 I have mentioned here. The features of Arduino Uno. Let's go through the features of Arduino Uno. All right. Don't worry. This is related to firmware. 100% yes. Firmware, yeah. Embedded systems. Right. So microcontroller is Atmega 328. Look at the operating voltage of that. 5 volt. Operating voltage is 5 volt. Input voltage 7 to 12 volt. Limits you can, yeah, 6 to 20, the limits are there. There are 14 digital input output pins. Digital input output pins does not make any sense. I know that, wait. And of which 6 provides PWM output. Can you understand anything? Obviously no. Analog input pin 6, you don't know what is that. Likewise, flash memory, blah, blah, blah. These like the specification of Arduino Uno. And let's have a look at that. Okay, this is what is there in the tier. The printed version of Arduino Uno. I think you can see it in the diode clearly, but not via the camera clearly, right? Fine. So I'm going to show this Arduino Uno in this via Tinkercad, how it works. Right. Okay. Let's get started. So those who have Arduinos, you can try connecting it. Try connecting your Arduino to a power source and make sure the LEDs are blinking. Come on. Let me know once you're done. Others, though, to those who don't have or those who find any problem with the Arduino, sir, you can connect or whatever, LED ka penna or whatever, what you can do is, come on, open up Tinkercad. Come on. Come on, kids. Let me know once you are done. We're going to do something. Let me know once you're done, kids. Tute link, please. What I said was, those who have Tinkercad, you must be in here. Those who have the Arduino, please make sure that you connect it via the USB cable to your computer and make sure the LEDs are turned on. Green and orange, right? Okay, now you must be having LEDs with you, right? How many of you have white transparent looking LEDs? How many of you have white transparent looking LEDs? Yeah? Okay, here we go. Then no worries at all. Fine. Shall we light a bulb? I mean LED. Why the Arduino? And at least be happy. Yeah? Okay? Fine. This is what you should do. Can you all see 3.3 volt here? Can you all see here 3.3 volt power line? Can you all see in the Arduino? There's a power section. There's a power section. Yeah? Netni, what you have to do is in the Arduino, there is a, you must have got a cable, USB cable to it. Come on, it's like connecting a mobile phone, right? Just take the USB cable and connect it to your computer. Very simple. Let me show you the cable. Wait. My cables, hey, cables come out. See? And then that's it. Connect it and this side to your computer. That's it. Job done. Plug it in. Come on. Use your strength. It doesn't connect. Arimba, it doesn't connect. Right. Fine. Right. Okay. Fine. Come on. Now, so here we have power pins are here. 3.3 volt, 5 volt output, ground and voltage in. Oh, okay. Fine. Look at this. Okay, done. Nitmi has done. Right. Great. Fine. So we have 3.3 volt, right? The physical kids, you must be having the physical kids in the sense the ones also having the Arduino boards physically. You must be having male female wires with you, right? Let me take the male female wires. How to identify a male female wire? Now don't ask that question from me. Let me tell you. Let me explain it to you. Don't worry. Right. So you have wires like this. Wait, let me turn on the autofocus. I have to use like all my technology to teach this to you. Right. So you have this kind of breadboard bias. These are your breadboard bias must not be like this small, yeah. You have breadboard bias set with you, right? These are called breadboard bias, yeah. Yeah, right. Those who have, those who don't have, don't worry, okay? You are still in here, don't worry. Don't worry. Fine. Now, I'm going to take one wire. Okay, wait. There are a lot of different types of wires. So this is specifically the type of wire that I want you to have. I'll tell you. There is male, female type. Wait. One side having, let's try to focus. Obviously, it's not possible. One side having the pin and the other side, let's focus. Come on, try. You can't. Wait. I'm gonna do this somehow. Blurred vision is what I want, and see where the blurry part is. Okay, see, I told you I'm gonna do this somehow. Okay, so you have one side male pin and the other side female. I mean, pinless is female, yeah. Can you understand it in that way, or you want more explanations to that? Yeah? Yeah? Fine. Understood? Whew. Right. Focusing modes. Bit interesting. So what you have to do is just connect your LED. Make sure that you have two wires. In your LED, you can find one pin is longer and the other one is shorter. Is that a manufacturer problem? Can you find in your LED one pin is longer and the other one is shorter? Yes or no? Could you find it? The long one is known as anode. Anode? Anode. The short side is known as cathode. Cathai? No, cathode. You got it? If you take the LED, let me tell it to you. Let me show you. Take the LED. Just first day basics. I'm going to draw the LED. I don't have a proper shape for that in here. Okay. That's not an LED. Okay. Let's say that this is your LED. LED has one pin which is long and the other one which is short. Let's say that this is an LED. Okay. One pin which is long and the other one is which is short. The long one is known as the plus side. Okay. The plus side, the positive voltage side, and the other one, yeah. And the other side is GND, ground side. Some people call it minus, right? And this is anode, and this is cathode side. All right, just that's it. That's what they are called. Okay, just don't worry. Just the names. Think of these things as, you know, some magical names. Yeah, anode and cathode. That's it. You got it. Now, if your family members are going to ask from you, what did you learn today? You can tell them, like, you know, we learned anode and cathode. Oh, what is that? Is it like some Merlin session to learn magic? Fine. Basics of electronics. Fine. Okay. Right. Don't worry. I'll be giving the recordings, right? Okay. Fine. So could you find out the long side and the short side of your LED bulb? Yeah. You must be able to find out. Otherwise, a big problem. Yeah. The long and short sides. Yeah. Very good. Very good, kids. Perfect. Right. Let me go back to here. What is this? I didn't do something like this. No, I don't want that. I don't want that. Wait, I really don't want you. No, I don't want the vibrate motor. I'm going to remove that. Fine. Okay. Fine. So we are about to connect this. So you have to take two cables to that male-female wires and then connect the female side to your LED. You can do that, you know. Yeah, connect the female side to the LED. Female side to the LED. Make sure that you have two colors. Make sure that you have two colors. The cables, two colors. Long side color and the short side color, keep in mind, okay? The long side color and the short side color, keep in mind. Are you all done with this? Come on. Let me show it to you how it's done. Focus. Let me show it to you how it's done. See? It's a connected one. Can you all see this here? Obviously, yes. Can you all see this here? It should be yes. So I have connected it. Wait, Tinkercad, wait. Okay, right. So, after connecting it, the female sides, so in my case, I have connected the long one to red wire and the short one to the brown wire. And then let's try doing this. You can see the two male pins, you can connect it to here, that is 3.3 volt. 3.3 volt, try connecting the positive wire to 3.3 volt and the short wire, the short one to GND. The short side of the LED to GND and the positive side to 3.3 volt. If you don't have the transparent LED, what will happen to your LED is that it will get burned, but not the transparent white one. Make sure it's 3.3 volt. Come on, you all done? You all done? LED burned. Perfect. Okay. Okay. Let me show how this can be done using Tinkercad. I'm doing it using Tinkercad. You will understand how to do this physically also when I'm doing it via Tinkercad. Right. So what I'm going to do is, I'm going to take an LED bulb from this list. I can find out LED bulb, please. Wait. Okay, wait. All right, I don't need that again. Yes, okay. Fine. So I have in the list of items, I can find LED bulb, just the LED one with the two pins. The first one, LED. So you can see here, the red one. I'm going to take an LED bulb. And color red, it's okay. And also I'm going to have a resistor, otherwise it will be a problem when connecting via this, especially resistor. Okay, wait, I'll zoom it in, don't worry, you will see that, So I have in my workspace, I have a resistor and also an LED bulb. Let me show it to you clearly. Right. Can you all see that I have resistor, LED bulb, and the Arduino? Come on. Can you all see this? Perfect. Okay. Now we need to find out the anode and the cathode, but before that, what I'm going to do is I'm going to connect this 3.3 volt of this one. I can just simply click on that, and then 3.3 volt of this I can connect to the resistor, just like that. To the resistor, right? Just to the resistor like that. 3.3 volt to the resistor like that. Why? To reduce the voltage to the resistor. All right? Fine. And the other end of the resistor, I'm going to connect to, I can see it here, to the anode of the LED bulb. If you look at the LED bulb, you'll be able to see the anode of the LED bulb, kids. Right? The anode of the LED bulb. Just like that. Okay? Anode of the LED bulb. If you like click on the pin, you can see, just even if you like move the mouse cursor over to it, you can see it will like give you a small text, show you a small text saying that this is the anode, right? And then take the ground and connect it to, I'll move it a little bit. Yeah, take the ground and connect it to the cathode of the LED bulb. Could you all do this? Come on. Are you all done with this? Come on. 3.3 via the resistor to the anode and ground to the ground pin of the LED, to the cathode. Right. So this is what you should do practically also. Right. Only thing is that you don't have a resistor with you maybe, right? You don't have a resistor with you maybe. So without the resistor, you can simply connect it to the anode if you have a transparent that bulb, right? It won't be a problem when we connect to the other digital pins, right? It won't burn in that way. So yeah, so this done. So if you have connected your Arduino, then it should light up, but in this case, it doesn't light up because I have not started the simulation yet. Fine. Tinkercad bulb is not lighting up. Wait, kids. For you to like make the Tinkercad bulb work, let's start the simulation. Initializing, and you can see the bulb is lit. Yes, it's working. It's on. Say yes. Got it? So virtually it's working and practically it should be working. Practically it should be working. Okay. Doing physically is more fun. That's why I told you to purchase the Arduino kits. Right. Both worked. Awesome. Both worked. Superb. Right. Wait. This is just, come on, turning on an LED bulb. Do you need to have an Arduino for that? Goodness. You can do it with like the two 1.5 volt batteries also now. Wait, kids. Wait for it. We are going to learn more things with the Arduino a lot in next week. 2 hours just consumed. Lot of theories, less practicals today. Next week, more practicals, less theories. Get ready with your Arduino kits and everything. Make sure that you have all the components with you. And it's better to have like some resistors if you need to have, like, it's not a must to have. It's not a must to have, right? So that's all for today. They are like, ayo, let's do more. Right? Fine. Just the beginning. We are going to do a lot of stuff. That's all for today then, kids. Bye, everyone. Bye, kids. Let me unmute. Let me allow you to unmute so that you can say bye to me as well. Yes, you are allowed to unmute.
Bye, sir.
Kids.
Bye.